Okay, you're trying to find the coordinates of a point on the unit circle. So the circle has a radius of 1. Remember from class, from the image that I've shown a few times of the triangle spinning around the circle, every point on a circle is formed with a right triangle starting here at the center. If you also just think about what we know about coordinates, when you're trying to find the coordinate of a point, a coordinate tells you starting from 0 how far horizontally you run, left or right. That should be an X. X tells you horizontal. Y tells you the vertical change, so how far you went up and down. Since vertical and horizontal are always going to form a right angle, we know that this forms a right triangle. I'm just going to draw the right triangle a little larger over here so we can start thinking about what's happening with this right triangle. So instead of stressing about learning something brand new that we need to do on the circle, we actually already know this. This is just a triangle like we did in our last unit. It's a right triangle because, again, vertical and horizontal meet at a right angle. The base of this triangle is X because that's how far over we go. The height of this triangle is Y because that's how far up we go. The hypotenuse of this triangle is the same as the radius of this circle. So the hypotenuse of the triangle is 1. The last thing to do is determine the measure of the angle right here. So this central angle here, starting in standard position, the initial side, and ending on this line that connects with P, the terminal side, is 140 degrees. Since the entire top half is 180 degrees, 180 degrees minus 140 degrees means that we only have 40 degrees left to get to 180. So this little piece in here is a 40-degree angle. So now, again, we can kind of ignore, we don't even need this circle anymore. We're just working with a right triangle, and we can just use our trig tools from our previous unit. I tend to always start with sine because it's in my brain that it comes first. So sine of 40 degrees now is equal to the side opposite the 40-degree angle, which is y, divided by the hypotenuse, which is 1. Now this becomes pretty easy because y divided by 1 is just y. So then I can quickly just take the sine of 40 degrees by typing it into my calculator, and I get approximately 0.64. Now, to find the cosine, some people like to use the Pythagorean theorem here. I actually think it's going to be, to find the x, I actually think it's going to be faster to use cosine because, again, I'm just going to have to type it into my calculator. So cosine of 40 degrees is going to equal x over 1. X divided by 1 is just x. And if I type cosine 40 into my calculator, I get approximately 0.77. I wrote 1 there, and I should have written x there. I apologize for that error. Okay, so now I have found out the sides of the triangle. Now, when we find out sides of the triangle, distance, right? The distance from here to here is this x value, 0.77. Now we do have to think about the coordinate plane again. Back on the coordinate plane, x is negative in the second quadrant because this distance we went was in a negative direction. So on a coordinate plane, your numbers x and y also have direction. So we have to use positive and negative to say which direction we went. A triangle is just about distance, and distance has no direction. So that's the only tiny little difference that now when we go to actually find the coordinate, we're going to have negative 0.77 for x and 0.64 for y. And again, this is an approximate coordinate. If this had been a 30, 45, or 60-degree angle, we could have found the exact value of the coordinate. But since it is 40 degrees, we're stuck with an approximation of the coordinate.